Hi there, my name is Noah Hirschhorn, and today I will be presenting a poster titled Atmospheric Observations of New Particle Formation in Ozone at Storm Peak Laboratory during the spring of 2014. This is work I did alongside Dr. Gannett Holler and two other students in the Holler Aerosol Research Team, Christopher Rapp and Angelina Miller. Let's get started. Today we're going to be focusing on atmospheric aerosols and how they're formed. Aerosols are defined as solid or liquid particles suspended in air. These particles can be emitted primarily or through secondary gas-to-particle reactions, which is what we are going to focus on today. Now, these gas-to-particle reactions occur under specific atmospheric conditions, where nanoparticles are formed from the gas phase by a process called nucleation, and then grow through a process called new particle formation, or as I will refer to it today, NPF. We care about aerosols formed from NPF because at proper sizes, under specific meteorological and chemical conditions, these particles can activate and become cloud condensation nuclei, CCN, which can affect climate by forming clouds. Now, gas-to-particle reactions require a gas, and one gas of interest are biogenic volatile organic compounds, BVOCs, which are a class of organic gases emitted from plants that have a role in both particle nucleation and growth. Whether or not BVOCs participate in nucleation and NPF depends on a variety of factors, including trace gases such as ozone, which can oxidize BVOCs, or in other words, react with the primary BVOC emissions to form products that then participate in particle nucleation and growth. For today's poster, we use aerosol size distributions to identify NPF events and then connect these events to ozone levels in the spring of 2014 in preparation for a larger study on the effect of BVOCs on new particle formation. You can read a little bit more detail about the specific instruments we use, but I do want to acknowledge two things pertinent to our study. First is that all measurements are taken at Storm Peak Laboratory, a mountaintop observatory in Steamboat Springs, Colorado, that experiences frequent new particle formation events, especially in the springtime, which is why we focus our study on the springtime. Second, I want to acknowledge how we identify new particle formation events. We use size distributions, which are pictured in Figure 2, to visually inspect and classify events as an event day, non-event day, or undetermined, and we only use events and non-events in statistical analysis. If you look over to Figure 2, I want to point out that the top picture is a non-event, while the bottom size distribution is an event. Now, this is an event because, as you can see, at about 11 a.m. Mountain Standard Time, there is a burst of nano-sized particles followed by growth to larger sizes. This is how we're able to classify events or non-events. Out of the 42 days considered for analysis, 23 were classified as an event and 19 were classified as a non-event. An additional 19 days were undefined and not considered in analysis. Of those additional 19 days, 12 were undefined due to instrumental conditions, and the other 7 were undefined because we couldn't agree whether to classify it as an event or non-event. With a separation of ozone of new particle formation event in non-event days, we're able to take a look at ozone throughout the time period. What you can see in Figure 3 in the top right corner of the poster are 24-hour averages of ozone split by either event days or non-event days. The yellow shading represents time between 12 and 20 Mountain Standard Time, which is the time that new particle formation is most likely to happen. What we see is, especially in the afternoon, events are lower than non-events. Now, this is kind of contradictory to what I would have expected, because UV radiation is associated with NPF events, but also ozone production. So seeing lower ozone during events is quite a surprise, and we're going to do more work to identify the causes of this. In conclusion, new particle formation events occurred on 55% of days from February 1st to April 2nd, 2014. Ozone concentrations appear to be lower during NPF event days compared to non-event days. Future work aims to not only expand the record of NPF, but also connect them to ozone concentrations to determine whether ozone's participating in the chemical reactions, or the lower, if that trend continues, ozone concentrations are due to other factors. Once BVOC measurements are taken, we will be able to contextualize the patterns of trace gases, NPF, and BVOCs to determine the true contribution of BVOCs to new particle formation. I'd like to thank you for coming, and it especially acknowledge the Global Change and Sustainability Center for their support of this research. Thank you and have a great day.